Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hello, lesson 34. Hello there, unknown angles. Well, let's make these unknown angles known by using the trig we learned in this module. So here we go, classwork opening exercise, part A. Dan was walking through the forest when he came upon a sizable tree. Could Dan see the forest for the trees? That's the question. No, it's not. Let's move on. Dan estimated he was about 40 meters away from the tree. Time out. That would be this distance here, my x. Okay, the x is approximately 40 meters away from the tree, 40 meters away from the tree. When he measured the angle of elevation, so Dan is looking up and he sees the top of the tree and the angle of elevation is 35 degrees. We will definitely assume that that is a right angle. Okay. And if Dan is about, so there it is, 35 degrees. It was already marked for us. Dan is about 2 meters tall. So Dan's pretty tall. He's 6 feet tall, approximately 2 meters. And so do not forget to calculate that into our final answer because his eyes are already 2 meters above the base of the tree. So when I find this side, which I'll call y, I have to add 2 meters to get the total height of the tree. So I know opposite, I know adjacent, so I know that that will be the tangent. The tangent of theta equals opposite. Okay, and it's not a bad idea to write this opposite over adjacent. Okay, a little reminder of our trig functions. So the tangent theta in this case is 35 degrees, equals the opposite, which is y, over adjacent, which is 40. Okay, so to find y, I just multiply both sides by 40, and that will give me y equals the tangent. No, it doesn't. Forgot my 40. Hello. 40 times the tangent of 35 degrees. So then I put that in my calculator and I get 40 tan 35 and hit enter. And I get 28.008. So it's pretty close to 28 meters. Do not forget that his eyes were already 2 meters off the ground. So I need to add 2 meters. So tree, the tree equals, or let's say it's an approximation because that was a decimal, 28 plus 2. The tree is approximately 30 meters tall. And there we go. Okay, part B on page 2. Dan is still in the woods. Dan was pretty impressed with this tree. That was how tall? 30 meters tall? From here to here? Okay. Okay, so then he turned around and saw a bigger one, also 40 meters away. So this length right here is 40 meters. He's in between two trees that are 80 meters apart because this was 40 meters from the prior problem, wasn't it? Wasn't it? Yes, it was. Okay, so now he thinks this is also about 40 meters away. And wow, he said, I bet that tree is at least 50 meters tall. So if this tree is 50 meters tall, let's just say it's 50 meters tall, then he thought for a moment, if it is 50 meters tall, I wonder what angle of elevation I would measure from my eye level to the top of the tree. So now he's asking himself, I spend too much time in the woods. How much is this angle? What angle will Dan find if the tree is 50 meters tall? Explain your reasoning. Well, again, do not forget that this is 2 meters. So Dan is 2 meters tall. So this side y is not 50, it is 48 meters. We assume that's a right angle. So we have opposite over adjacent, which is tan. So tan equals opposite over adjacent. And I'm going to write this just because it's a nice reminder. Every time we do a problem, write a formula, substitute in the givens. And that is really messy ADJ. All right, so write a formula. That's what I'm doing. Substitute in the givens. tan theta, by the way. So now I'm going to say the tangent of theta, because I don't know the angle measure here. So that's why it's nice to write the formula. Our unknown is theta. Opposite is 48. Adjacent is 40. So to find theta, I move tangent over to the other side. So theta is going to equal, when we take the inverse of something to cross the equal sign, tangent now becomes the tan inverse on the other side of 48 over 40. Capiche? So I open up my calculator, I turn it on, clear, and I want to do second tan. See right up here, it says tan to the -1 and it's blue. Use the second button, tan to the -1 is the inverse of tangent. And then I put my fraction in, 48 divided by 40, and that will give me an angle approximation of theta is approximately 50 degrees. Okay, and we are done. Okay, moving right along to page 3 brings us to exercises 1 through 5. So here's exercise 1, parts A, B, C, and D. It says to find the measure of angle A through D to the nearest degree. So angle A in part A, angle B in part B, angle C in part C, and angle D in part D. These are exercises. Pause the video, see if you can do them, and then come back and check your solutions. Okay, without any further ado, I'm going to assume you pause the video and you're now checking your answers. So here we go. So here is our reference angle, angle A, and this is ADJ over here, and this is HYP over here. Adjacent over hypotenuse is cosine. So I'm going to say the cosine of A equals ADJ over HYP. The cosine of A equals 13 over 20. Therefore, A is going to equal the cosine inverse of 13 over 20. So A is going to equal, calculator, second cos 13 divide 20, enter, and it's approximately 49.5. So A is approximately, to the nearest degree, 49.4 would just be about 49 degrees, rounding or truncating. So A is 49 degrees. Okay, B, let's change colors. B, where's my marker? There we go, B. B is right here. With respect to angle B, we know opposite and we know hypotenuse. Opposite over hypotenuse is sine. So I'll do that over here. The sine of B equals OPP over HYP. Yeah, you know me. And the sine of B equals opposite 40 over 42. Okay, we could reduce that, but why? Okay, so I'm going to use another term here, not to confuse you, just to, if you ever run across something in a textbook in future math classes and you see this word and you're like, I don't know what that is. You actually do, you just have never heard it called that. So I'm going to call it that. When we do the inverse to get sine over to the other side, there's another name for it. So over here, notice I have cos inverse, cos to the -1. Another way to say that is arc sine. And you could say arc cosine or arc tangent. So if you use the word ARC instead of the -1, it means the same thing. So I'm going to say arc sine of 40 over 42. So B equals, and then I'm going to go in my calculator and I'm going to hit second sine. Sine to the -1 is the same as arc sine, and it's going to be 40 divided by 42. And I get approximately 72 degrees. So I'm going to do a squiggly here, 72 degrees. Okay, and let's just keep moving right along here. Part C, here is my reference angle. With respect to my reference, this is OPP again. This is ADJ. Careful, tangent of C equals OPP over ADJ. Okay, so the tangent, no, we're not doing can. The tangent of C equals OPP over ADJ. I usually don't use arc sine, but I just wanted you to be aware that arc sine is the same as sine inverse. So I'm going to say C equals, and I'm going to use tan to the -1, which is tan inverse. That's the one I'm more used to using. I don't ever write arctan when I'm doing my problems. And C equals, and I go to my calculator and I hit second, tan 14 divide 29, enter, and I get 25.7 more than 5, round up approximately. I always forget to put approximations. Approximately 26 degrees. Okay, and moving right along to D. D is this reference angle. With respect to this, I have my opposite. I have an hypotenuse, HYP. Opposite over hypotenuse is sine. So the sine of D equals OPP over HYP, opposite over hypotenuse. The sine of D equals 68 over 85. So therefore D equals the sine inverse of 68/85. Go to my calculator. Second, sine 68 divide 85, and I get approximately 53 degrees. So D is approximately 53 degrees. So hopefully you got these answers. Okay, here's B. A was 49 degrees, B 72, C 26, and D 53 degrees. Alrighty, page 4, number 2. Remember, these are still exercises, so pause the video, see if you can do these, come back and check. Here we go, number 2. Shelves are being built in a classroom to hold textbooks and elves and other supplies. The shelves for the elves will extend 10 inches from the wall. Okay, so here's the shelf, marked 10 inches from the wall. Support braces will need to be installed to secure the shelves. There's our brace. That is our hypotenuse. Okay. The braces will be attached to the end of the shelf and secured 6 inches below the wall. So now we know the shelf length is 10. The brace touches the wall at 6 inches below the shelf, and the brace is here. What angle measure will the brace and the shelf make? So it's asking this angle measure. So with respect to my reference angle, I know opposite, the wall, and I know adjacent, the shelf. I do not know the length of the hypotenuse, which is the brace. We can find that by doing the Pythagorean theorem, 6 squared plus 10 squared equals brace squared, but we won't, this is not asking that, we're just finding angle X. So you would say opposite over adjacent is tangent. So the tangent of X equals opposite over adjacent. The tangent of X equals 6/10. X equals the tan inverse or arctan of 6/10. Go to my calculator. Second, tan 6 divided by 10. Enter, and I get 30.96. And let's just round to 31. So X is approximately 31 degrees. Okay, number 3. A 16-foot ladder leans against a wall. The foot of the ladder is 7 feet from the wall. Whenever you get a problem like this, draw a diagram. I'm going to draw a diagram. So here is my diagram. It's very simple for me using that tool. A 16-foot ladder. So the ladder is at the angle. So this is 16 feet. Leans against a wall. The foot of the ladder is 7 feet from the wall. So the wall is right here. This is the floor. And the foot of the ladder is right here. And it is 7 feet from the wall. Okay, so there's our diagram. Find the vertical distance from the ground to the point where the top of the ladder touches the wall. So we want to know, I'll call it y since it's vertical. Okay. So in this case, we don't know this angle. We don't know this angle. It could be 189, 288, 387, and so on and so on. So the only thing we need to do here is find a missing side. This is the Pythagorean theorem. A squared plus b squared equals c squared. I always put my hypotenuse first so I don't mess it up. This has to be by itself over here. A and b can be interchangeable. I will say A, well, it doesn't matter, but I'll say A is 7 and b is my y. So 7 squared plus y squared equals 16 squared. 49 plus y squared equals 16 squared. What's 16 squared? I don't remember. 16 squared is 256. 256. Subtract 49 from both sides. So if I subtract 49, that's 207. So y is approximately the square root, or actually it's not approximate yet, it's exact. Y is equal to the square root of 207. I don't know what that means. I cannot picture a square root of 207. So I'm going to use my calculator and find the approximation. Square root of 207 is approximately 14 feet. Let's round to nearest foot. So y is approximately 14 feet. Okay, so now that we know all sides, I will erase this y here and I'll put my answer in, 14 feet. And now B says to determine the measure of the angle formed by the ladder and the ground. So this is our theta right down here. When you know all three sides, you can do sine, you can do cosine, or you can do tangent. It doesn't matter. I see 14 and 7, they're multiples of each other. I'm going to use that just to make it easier. And that's sometimes what you are trying to look for, is to make your life easier. So opposite over adjacent's tan. So I'm going to say the tangent of theta equals OPP over ADJ. Write my formula, substitute in my givens. I don't know theta. I know opposite is 14. I know adjacent is 7. I'm looking for tan theta to equal 2. 14 divided by 7 is 2. So theta equals the tan inverse of 2. Second, tan 2, enter, and I get 63 degrees. So theta is approximately 63 degrees. Okay, you should get the same answer if you did cosine inverse of 7/16 or sine inverse of 14/16. Okay, and I got thinking about that. And maybe I should not have used this answer. Why? Why? Because y was an approximation and these are exact. So that was my bad. I wasn't thinking about that. That's an approximated value. We were given this as 7 and this is 16. So if I did cosine of theta, which is adjacent over hypotenuse, then I would say cosine of theta equals 7/16. Theta equals the cosine inverse of 7/16. And as you can see, I got 64 degrees, not 63. So then I'd say theta is approximately 64 degrees. Okay. Now, if I were giving this on one of my quizzes or tests and I saw your work and you got an approximation, 1 degree difference, I would not take off from that. But for future reference, if you are doing multiple step problems, try to avoid approximating before the very last step. Okay, what page is this? This is page 5, problem number 4. So hopefully you've tried this. Pause the video. If not, try it. Come back, see how you did. So it says here, a group of friends have hiked to the top of Mile High Mountain. Is that it? No, that's Mount Etna. When they look down, they can see their campsite, which they know is approximately 3 miles from the base of the mountain. Sketch a drawing of the situation. All right, so let me get a triangle. There's my triangle. Let's use green. And, oh, I don't know, let's just say the mountain comes up like this. Okay. All righty. So there's our mountain and there's a triangle. So this is the base of the mountain. A group of friends have hiked to the top of Mile High Mountain. When they look down, they can see their campsite, which they know is approximately 3 miles from the base of the mountain. Okay. Well, this isn't quite working. So let me switch this a little bit. So let's see. Let's say the base is there and the mountain goes up like so, like that. Okay. So from where they're standing, from the base of where they're standing, if you will, is 3 miles. Okay. When they look down, they can see their campsite. So the campsite's here, which they know is approximately 3 miles from the base of the mountain. Okay. Anywho, there we have it. It might be more so like this. Let's say it's more like a cliff and it goes like that. So therefore it's not coming down like this. That make more sense right there. So they're like up on this cliff at the top of the mountain and their campsite's 3 miles from the base. All right, so sketch a drawing of the site. There it is. Whoop. What is the angle of depression? Well, keep in mind what angle of depression is. So think of it as you're standing here and oops. And you're standing here. Let me try that again. Okay, I'm struggling here. It's real. How about that? And then finally that. Okay, so you're looking straight out from here. So if this is horizontal with the ground, the angle of depression is not inside the triangle, but out here. Angle of depression is the angle of your line of sight looking down and the horizontal. The angle in between is what makes your angle of depression. So here's the angle of depression. So it's saying, what is the angle of depression? So if this line of sight here is parallel to the ground, then we have a transversal here, and therefore this angle inside the triangle is also equal to theta. They're congruent because they're alternate interior angles. So I know that this is 3 miles, and I know that this is my angle of elevation or angle of depression. So therefore it's equal to the angle of elevation if you were at the campsite looking up at them. Let me read this again. A group of friends have hiked to the top of Mile High Mountain. So they hiked up there from this side probably. When they look down, they can see their campsite, which they know is approximately 3 miles from the base of the mountain. Oh, my fault. It's right here. Mile High Mountain. So this is 1 mile here. 3 miles from the base, right angle. So we have a right triangle with 2 sides, and we want to find this angle. So the angle of depression is equal to the alternate interior angle down here. So that's opposite over adjacent, which is tan. So the tangent of our angle equals opposite over adjacent. So the tangent of the angle theta equals 1 over 3. So the theta is going to equal the tangent inverse of 1/3. I get my calculator out, turn it on, second tan 1 divide 3. Enter. And I get 18.43. So theta is approximately 18 degrees. Okay, page 6, problem number 5. A roller coaster travels 80 feet of track from the loading zone before reaching its peak. Okie dokie. So think of this. You leave a platform and you go up, you go up, you go up, you go up, you reach the peak, and usually it's woo. Okay, there's our roller coaster. Do you like that? A roller coaster travels 80 feet of track from the loading zone before reaching its peak. So I'm going to draw a diagram. The horizontal distance between the loading zone and the base of the peak is 50 feet. Okay. All right, so I'm going to draw a triangle. And I'm going to have to flip it. So flip, left, right. Okay, and now move it. So here's its peak. Let's just say right here. Let's just line this up. Actually, let me just draw a new line rather than try to fit this triangle. So just delete this. So anywho, the track, the loading zone is here. So we come along here and then it climbs up and then it takes a quick descent like so. Okay, so here's our loading point right here. The horizontal distance from the loading zone, between the loading zone and the base of the peak. So the peak straight down from the peak is right here. It's a 90-degree angle, and this distance is 50 feet. Model the situation using a right triangle. So there it is. So I know the hypotenuse in this case is 80 feet. Okay, 50 feet from the base, 80 feet of track from the loading zone to the peak. So that's our hypotenuse. At what angle is the roller coaster rising according to the model? So that would be this angle here. What is that angle of elevation? All right, so based on this angle of reference, this is adjacent and this is hypotenuse. So adjacent over hypotenuse is cosine. So I'd say the cosine of theta equals ADJ over HYP. Now down here it says at what angle is the roller coaster rising? So we want to find theta. So I substitute in my givens. Cosine of the angle equals adjacent, which is 50, over the hypotenuse, which is 80. Okay. And therefore, when I simplify and solve for theta, I take the inverse cosine of both sides and I get cosine inverse of, and I'm just going to reduce this because it's easy. The zeros cancel, 5/8. So then I'm going to turn my calculator on and I'm going to hit second cos for cos inverse. 5 divided by 8 equals 51.3 degrees. So theta is approximately 51 degrees. And we're done. Okay, page 7 brings us to the end of lesson 34. Review this lesson summary and keep in mind, notice down here, we can use the calculator to use, so arc sine is sine inverse, arc cos is the same as cosine inverse, and arc tan is the same as tan inverse. Review your lesson summary and go do your problem set.